Hello everyone. Let's see another program in the RISC V, that is addition of n numbers. So in my assumption I am adding randomly 5 numbers, and these 5 numbers are begin from 48 location. So to address the memory location I am taking one of the register x20, and if we add 5 numbers totally there will be 4 operators. That means there are 4 addition operations. So whenever the same operation is repeated for the couple of times, there I am using loop. So totally we are adding 4 additions. We are performing 4 additions. For the counting 4 additions, I am using x21 register. So after addition of every 2 numbers, you have one result. That result is taken by x7. So x7 is result for the sum of a number. At the end I'm going to move result back to the memory location. Okay, let's start the coding part. X20 for pointing the memory, and the target location is 48. So this is the add immediate instruction is used to moving the number or data into the register. Add immediate x20 comma x0. X0 is also one of the register, and the specialty of x0 is it is always 0. X0 value is by default is 0, and which is non-alterable. This is the 0 is adding with the 48. So remember, 48 is the decimal representation, but always the system is taking in terms of hexadecimal number system, right? So here this 48 number and the value of x0 is always 0, both are added and result is 48. So in this way you are transferring 48 address into the x20, and we have a counter value 04 which is transferred to x21 by using same instruction. Now x21 for the counter, right now. So now from the memory location one by one get the numbers. So LW instruction is used to access memory. So I'm taking first number into x7. How the memory location is forming, how the address is calculating. So in the as per the syntax, this is the constant is adding with the value of x20. Right now x20 has a number 48. So both are added, 48 as well as constant 0, both are added. 0 plus 48 again 48. So from that particular location I am taking first number into x7 register. Okay, and we have a second number from uh, after 4 locations. Why? Because here uh, we are using the simulator Venus that is supporting for the 32-bit data, and every memory location will capture only 1 byte. So we are adding 32-bit number. So to store every 32-bit number, which requires totally 4 locations. That's why to address next second input data, incrementing x20 pointer to the next fourth location. That means 48 plus 4. That's why here in order to increment the x20 register, I'm adding 04. So why I'm adding 04 means we have a second number from after 4 locations of current x20 register, that is 48. Okay, so after incrementing x20, the pointer is targeting second input number, and again with the same instruction I am taking second number into x8 register. Now by x7 I have first number, by x8 I have second number, both are added, and we have a result which is taken by x7 register. So first two numbers successfully added. Alright, so this is the same task will repeat for 4 times. Instead of writing every time, I want to repeat the loop. So I'm using the down counter. Right now, one addition operation completed. So after completion of that, I'm decrementing the counter value. So I have a counter value by x21 register. So this is the statement is also used to perform subtraction. So here I mention -1. That is the symbol will perform the subtraction. So initial x21 value, how much? Initially x21 value 4 number. If you subtract, that comes to 3 number. So after that I am comparing x21, that is 3 number, with x0 is 0. If equal, it is going to be terminate. Sorry, yeah, yes, if both are equal, it will execute next sequence of instructions. So actually those two are the statements for repeat the loop, and in this statement I'm decrementing the counter. After decrementation I'm checking whether x21, that is our counter value, is equals to 0 or not. If our counter value is not equals to 0, then repeat the operation. That means perform the addition of the third number, addition with the third number. So if both are not equal, jump to back. Branch means jump to back. It will come to this statement, and in this one what we are doing, so we are doing simply incrementing the pointer, increment the pointer. So our pointer at second number, now again if it is incremented, that will point out the address of a third input number. Now by exit register we are taking third input number by using this statement. Now we have a first result by x7 register, and in excite we have a third input number. Both are added, result comes to again accumulate as a x7. Again decrement the counter, that is 2 number, and again comparison. If x21 value, x21 is our counter, if our counter value is not equals to 0, again repeat the addition operation. So that will repeat until the counter value reaches to 0. Once it is reached to 0, then we want to store the result back to the memory. In order to store the result into the result into the memory, I am adding 04 again. Why? Because we have to increment the memory pointer, that is x20. In order to increment the x20, I am adding 4 locations. So by x7 I have a result now which is transferred to memory location. This is the coding part explanation. Let's see the simulation part. So coming to Venus editor window, here we can copy the program. It will not accept the, so just I'm removing the comment section, otherwise might be you will get errors. Okay, after writing the code, come to simulator, click on the reassemble or assemble. So this is the entire code. Okay, and now coming to the memory. So 48, that's equivalent hexadecimal value is the 30 number actually. 30. Come down here, we can enter Rex 30. Uh, 48 is, so 48 divided by 60. Let's execute the program. Registers. So our memory pointer is the x20 register. Come to x20, x20. Let's take the step-by-step execution. Yeah, now x20 has a 30. That means our memory location begin at 30th, and x21 for counter value, that is 04. Okay, now we are ready to access. Actually we have to substitute input numbers right now. So our location is 30. So this is the 30th location. Here I'm going to give input numbers 1, 1, 17 is decimal number. Its equal hexadecimal value is the 1 1. Here I'm giving second input number 30. Let's take all same numbers. You have to give totally 5 input numbers. You can give any numbers, no issue. Okay. And 44th location you will get final result. Just click on the step by step, and also you can observe now if you after execution of this statement x7 register will get first number x7. Right now x7 value is 0 0. Yes, now x7 equals to all ones. Implement the pointer and then get second number by x8 register. X8 as per the given memory locations it wants some 110p 1111. Even in the memory also we have some we have a same values 110p 1111. Okay, so as per that we got the second number, and then we are adding both the values, and again result will comes to x7 itself. X7. So this is the value is replaced by result. Now this is the current result. Okay. Now let's look at the this is the process will repeat for addition of 5 numbers, and finally in the 44th location you will see the results. You can see the program execution. So it is repeating until the count value reaches to 0. Store word. Yes, now 44th location has numbers like 55 4f 55 55. That's the word end of the result. So equal is the terminate the program. Okay, in this way you can practice every program, every instruction in this simulator. Thank you.